And my name is Alex Kumar, biologist with the Fish and Wildlife Service based out of Fort Collins, Colorado. And now I'm going to talk about extending the sagebrush conservation design to imperiled rangeland birds. And I want to start off by acknowledging my co-authors, Jason Tack, Kevin Doherty, Joe Smith, Beth Ross, and Jeff Bedrosian. Okay, so stepping back, we're at a rangelands conference. Why are we talking about birds? Some of you might be familiar with the recent paper that came out in Science in 2019 that basically showed that since 1970, we've lost almost 3 billion birds from our ecosystems across North America. And it's important to note that these losses weren't spread evenly across all biomes. Instead, they were concentrated in areas such as grasslands and arid lands. And as Tina showed earlier, we're also seeing declines in the sagebrush biome that mirror these declines in grassland bird species. So again, that green line is showing the overall decline from 2020 or from 2000 to 2020 in these core sagebrush areas, the best of the best sagebrush habitat. And it approximates, or it amounts to about 750,000 acres every year being lost of this core habitat. So to help combat this loss, we had partners come together and formulate the sagebrush conservation design as sort of a plan to proactively restore this biome. And this design identified core sagebrush areas in dark blue, and these areas had high levels of sagebrush ecological integrity. We can compare that with growth opportunity areas in light blue. These had more moderate levels of sagebrush ecological integrity, and other rangeland areas in tan, low levels of sagebrush ecological integrity. And so when I say sagebrush ecological integrity, what I actually mean is a composite measure of 5 different ecosystem attributes. So it's calculated by combining the positive effects of sagebrush cover, perennial grass cover, and the negative effects of annual grass cover, human modification, and conifer cover. So we can combine those and come up with core sagebrush areas. These areas have high sagebrush cover, high perennial cover, and lower annual grass cover, human modification, and conifer cover. Okay, so the overall question that we were interested in answering here is, can conservation directed at threats to core sagebrush areas also confer benefits on declining bird species? So one way to think about that question is, if we were to follow the guidance in the sagebrush conservation design and direct conservation actions mostly at these core sagebrush areas, maybe even stop the decline that we're seeing in these grassland birds. So we had 3 main objectives. The first was to answer the question, is SCI predictive of songbird abundance? Then we wanted to examine songbird population trends over time and see if they differ between core sagebrush areas, growth opportunity areas, and other rangeland areas. And finally, we wanted to look at the relative influence of the 5 different components of SCI. So again, sagebrush cover, perennial grass cover, annual grass cover, human modification, tree cover. What are the relative influences of these 5 main components on songbird abundance? And so we chose 3 different focal species: sagebrush sparrow, brewer's sparrow, and sage thrasher. We chose them for 2 reasons. They've been shown in the literature to be highly associated with sagebrush ecosystems. A lot of times they're referred to as sagebrush obligate species. And all 3 of these species are showing varying amounts of population decline recently. And so we used data from the Breeding Bird Survey, which is a continental-wide survey that's been implemented since the 1960s. We only used data from 1998 through 2020 to correspond with the data that was used in the SCD, but I do want to make the point that this represents a lot of data. So if we combine all 3 species, that equals 550 distinct survey routes and almost 400,000 different data points. So it really is a wealth of data that we're allowed to analyze, and it's a really cool opportunity. And for those of you who aren't as familiar with BBS, basically there's different survey routes. Each route consists of 50 different 3-minute point counts spaced half a mile apart. And so if you're a surveyor, you're typically driving a vehicle along a road, stopping every half mile, getting out and doing a point count. So you're gonna get out and listen for birds during 3 minutes and record all the birds that you hear. And these surveys are done once per year during the breeding season, which corresponds to late May into early July. So once we got that BBS data, we combined it into a Bayesian hierarchical model. So again, the response here was just the individual point counts. And the main predictor that we were interested in was sagebrush ecological integrity. We also ran another sets of models that, instead of using SCI as the predictor, instead used the 5 individual components of SCI. Then we wanted to include known sources of variation in our model. So we put random effects for things like year, observer, survey route, point count location. And we included a fixed effect for whether or not it was the first time an observer was running a particular route. And we included this fixed effect because it's been shown in the literature that the first time someone runs a survey route, they typically have lower counts. They're still learning the area. They might not be as familiar with the birds. And so we wanted to include that into the model as a known source of variation. So on to the results. What did we find? So if we focus in on the beta coefficients on the left, we see positive values for all 3 species. And so what that means is higher levels of SCI is associated with higher levels of bird counts. And we can also see that the 95% credible intervals for each species don't overlap 0, again, providing strong evidence that as you increase SCI, you're going to see a positive response in these bird populations. Then if we look on the right, we have a graph. This shows the results for sage thrasher, but it was similar for the other species as well. And we took the predicted relative abundance from the Bayesian models and binned them into core, growth, and other areas. And then we have the median counts shown in blue. And so we have a median of about 0.5 for the core sagebrush areas, which is more than double the median count for growth opportunity areas, and about 10 times more than other rangeland areas. So again, really strong evidence that these core sagebrush areas are supporting higher amounts of birds. What happens if we look at trends over time? And so I want to first focus on that top line. This is showing areas that started in core sagebrush areas in 2000 and stayed core throughout the duration of the study. And if you look at that line, it's fairly stable. There's probably a little bit of a decline over time, but there's also some cyclic population dynamics going on as well. And if we compare that line to the other 2 lines, we see that overall, we're seeing much higher counts there. Again, consistent with our findings on the previous slide that these core areas are supporting higher levels of these bird populations. We can contrast that with the bottom line, the dashed or the dotted line there with the triangles. These are areas that were other rangeland areas at the beginning of the study and stayed other rangeland areas throughout the duration. Fairly consistent population trend, but existing at pretty low densities. Then we can contrast that with the middle line. And so this shows core or areas that started as core sagebrush areas, but by the end of the study, they had transformed over into other rangeland areas. And that's where we see the strongest population declines. And so if we look at the beginning and end of that duration, we can see that there was a 58% population decrease in areas that started in core sagebrush areas and transitioned to other rangeland areas by the end of the study. So again, as we're seeing declining SCI values, we're seeing declining bird populations to match that response. And then finally, what are the relative importance of the 5 different components of SCI? And so we have a graph of the beta estimates. And so how you can interpret this is the further away these beta estimates from the model are from 0, shown by that dash line, the more important they are at structuring these songbird populations. And I just want to note here, we're presenting the Q values. And so that means that we actually took the raw cover values and transformed them. And that's how we calculated SCI in the original sagebrush conservation design. But for interpreting this graph now, one way to think about it is there's a negative sign in front of trees. And so that means we penalize increasing tree cover. Whereas for sagebrush, you see that positive symbol there. That means we're rewarding increasing sagebrush cover. So if we look at tree cover, we can see that decreasing tree cover was associated with an increased response in all 3 of our songbird populations. And the beta coefficient estimates for tree were furthest away from 0, showing that tree cover is probably the most important of these 5 components in structuring, on average, all 3 of these species. Sagebrush cover is next with a positive response on all 3 species as you increase sagebrush cover. Annuals is next, where we see all 3 species responding negatively to increased annual cover. For human modification, we see that if we decrease human modification, we'll get a positive response for brewer's sparrow and for sagebrush sparrow, but sage thrasher is unaffected. Their 95% credible interval overlaps 0 in that case. And then for perennials, we have the most equivocal support here because we see that if we increase perennial cover, we get a positive response for brewer's sparrow, but we actually get a negative response for sagebrush sparrow. and sage thrasher remains unaffected. So we can wrap up. The bottom line is, generally speaking, if you're conserving core sagebrush opportunity areas, the birds are getting the memo. Conservation actions designed to grow the core should positively impact these sagebrush obligate songbird species. And generally, we found that treatments that are designed to decrease conifer cover or increase sagebrush cover are probably going to be more beneficial to these particular species than other restoration techniques such as seeding perennials or treating invasives. But with a statement like that, there's always a caveat. That's really a species-specific responses if you're interested in species-specific conservation. So for instance, if you're really focused on conserving sagebrush sparrow, you probably wouldn't want to put a lot of efforts into reseeding perennials because that's been shown to have a negative response of sagebrush sparrow. But generally, if you're thinking about ecosystem level conservation, then you should be focusing on decreasing conifers and increasing sagebrush cover.